Welcome back to FuzeTox channel. In this video I'll try to explain my solution for 5Q kata square sum simple. This is a simple version of other square sums. So we have a description, square sums, right function, square sums row, or square sums row, or square sums row that. Give an integer number n in range 2 to 43. It turns array of integers 1 to n arranged in a way so sum of each two consecutive numbers is a square. Solution is valid even only if following two criteria are met. Each number in range from 1 to n is used once and only once. Sum of each two consecutive numbers is a perfect square. So we have an example for n equal to 15. Solution could look like this. 9 and 7. It's sum of this is 25. 7 to it's sum 9. It also perfect square, and it continues until the 8. Verification: all numbers are used once and only once. When sorted in ascending order, array looks like that, from 1 to 15. Sum of each two consecutive numbers is a perfect square. So yes, 16, 9, 16, 25, 9, 25, and so on. If there is no solution, return false. For example, if n equal 5, then numbers 1, 2, 3, 4, 5 cannot be put into square sums row. 1 plus 3 it's 4. 4 plus 5 9, but 2 has no pairs and cannot link 1, 3 and 4, 5. Have fun. So let's go to the code. So let's create a helper function. First of all, let's create result array. It's empty array. Also, let's return GFS helper function, which accept our result, new set, because only one number should be once in array. And after that, let's up to parameter is n. So let's check if it's true. If it's true, let's return our result, and if not, let's return false. So let's create helper function. Set and n. This helper function we should check first of all if set size equal to n. Let's return true. If it's returned true, it returns r. R is results in array. So let's iterate from I equal to, from I starts from 1, I less than or equal to n, and let's update I. So if our set has our I, let's continue. If results in array length and math square root of r with index 0 plus I and divided by 1 not equal to 0. Let's continue. And that set at our I and results in array on shift I. So in this, so let's recursively call DFS. If DFS are set n, return true, R shift and set delete I. And if it's not find the right row of unique elements, let's return false. So let's test it. One mistake. It works. So let's attempt. It also works. So let me explain what will occurs in this function. So helper function DFS accepts R new set. It's a set of unique elements and number of max elements of this array. If it's true, it returns results in array instead of its return false. So in helper function DFS, we have three parameters: R, which results in array, set of unique elements, and n, which is number of max n of elements. This code check if unique set of size equal to max length of this array, it should return true, and after that it return results in array. So in this code we iterate all the numbers from 1 to n, and for each number it checks if the number is already in the set. If so, it skips to the next iteration in this code. It also checks if square root of the sum of the first element of the row n is integer, of the row R and I is integer. If not, it skips to the next iteration. If the condition are met, it adds I to the set and the beginning of the row R, then it recursively calls itself with the updated row and set. If no valid row is found, it removes the first element and remains I from this set. It continues the loop until all the numbers have been checked, and if it's not find numbers, it returns false. So finally, let's submit. Thanks for watching. Bye.